Tom is on a budget. Something that he always seems to be able to find money to do is snowmobile. He's planning his day trip from Barrie to Collingwood using Ontario's snowmobile trails. He needs just enough gas to make his road trip, nothing more. He's done his research and he knows that there is an Esso gas station that is easily accessible from the trails in Barrie and also in Collingwood. Both are offering the same coupon options. These are examples of coupons that Tom could have found at Esso gas stations, but of course, we don't have that information just yet.
So our question is, what is the most cost-effective way for Tom to get from Barrie to Collingwood and back?
Based on the very little amount of information that we are given, these are the assumptions that we had to make in order to answer the question. This might be a good time for you to pause and read through them.
Method 1. First, we'll attempt to figure out the cost of traveling the total 200-kilometer road trip with only gassing up at the beginning of the trip. Using the assumption that the tank is only 25 liters, we need to figure out if Tom's snowmobile can make it to Collingwood and back in one tank. You'll see that we've shown two different ways of doing this. One uses multiplication and the other uses division. For the sake of time, this might be a good time to pause to take a gander at how we found these numbers. Here, you'll see that the trip is possible to do in one tank of gas without needing to refill if Tom chooses to do so. Now we need to figure out which coupon deal is better for Tom's wallet, the flat $2 rate of the purchase price or the 10-cent per liter discount. Here, we made the assumption that Tom only wants to spend his money to get back into this driveway with the least amount of gas remaining in his tank. Knowing that we need 20 liters of fuel, we can create an algorithm to determine how much the trip would cost him in gas. So 20 liters of fuel times $1, which is the current price of gas, equals $20 in the fuel needed. $20 minus the $2 discount, or discount number 1, equals $18 for the total trip. 20 liters of fuel minus 10 cent per liter discount equals 20 liters times 10 cents equals 200 cents. We know that 200 cents is $2. So since we already know that the price of gas is 1 liter, we can subtract that $2 from the top of the price.
So, 20 liters of fuel equals $20. Discount number 1 offers a $2 flat rate, which equals $18 per tank after subtracting the $2 from the $20. Discount number 2 offers $2 off when purchasing 20 liters of gas at 10 cents per liter off of the price of fuel. Therefore, the value of the coupons are the same. Neither coupon saves Tom any more money than the other by only filling up once during his trip. However, Lexi and Heather made a good point. We never said that he couldn't use the same coupon twice. Tom is sneaky. He could have printed 2 coupons off the internet to use at different times. If he used the coupons at different gas stations, once in Barrie and once in Collingwood, on $10 of gas, the flat rate coupon discount would be $2, and the 10 cents per liter discount would be $1. If he uses a $2 off coupon at both, he only pays $8 each time, for a total of $16 for the entire trip.
So, if he chooses to put $10 or 10 liters into his tank at the beginning of his trip, his most cost-efficient method would be to use the flat rate coupon at the beginning of his trip and again halfway through. The most cost-effective way for him to travel would be to use the $2 flat rate coupon twice.
Method number 2. As an alternative method to the traditional algorithms that we use in the first method of solving our problem, we decided to approach the problem using visual representation in the form of charts and bar graphs. The first chart that you see compares the number of liters of gas in the snowmobile tank to the cost of the gas while using the $2 flat rate discount. The second chart on the right compares the number of liters of gas in the snowmobile tank to the cost of gas while using the 10 cents off per liter discount. As you can clearly see, we came to the same conclusion using visual representation of numbers than we did using the traditional algorithm. This is a visual representation of a double bar graph comparing the liters of gas put into the snowmobile tank to the cost of the gas. The blue bar represents the cost of gas in dollars without applying any discount. The red bar represents the cost of gas in dollars after adding the flat rate $2 discount. This would be a good time to pause the video and reflect on the double bar graph. This is another visual representation of a double bar graph comparing the liters of gas put into the snowmobile tank to the cost of the gas. The blue bar represents the cost of the gas in dollars without applying any discount. The red bar represents the cost of the gas in dollars after adding the 10 cents off per liter discount. This would again be a good time to pause the video and reflect on the double bar graph. By using double bar graphs and charts, we were able to visually demonstrate that the most cost-effective way for Tom to use his coupons would be to gas up in $10 or 10-liter increments. Knowing that we only have 2 gas stations close to the trails, he would need to stop twice in order to achieve this.